the activity diagram, how does that work? No immediate predecessors. A and B start, right? A here, B here, obviously with arrows, and I'm putting the numbers on the top as well. So A is 6, B is 9. Okay? All good? Then what's my end? I've got a C here, I've got a D here, I've got an E here, I don't have an F here, so F must be the finish. Alright? Yes? Then A, B, C needs A and B, D needs A and B. So C needs A and B. So if C is extended and I join it here with A, then either I do this and join it here, I mean maybe here, something like this, but then that fails the rule 1. Rule 1 says you cannot have multiple edges between two vertices. So that means there's a dummy. So you've got B coming here and a dummy going on top. That's the dummy vertex. Correct? And this goes on top and that becomes your C. All good? B is 9. Dummy is always 0. And I said this is B, 0. And C is 8. Right? So this is done, this is done, this is done. Now D also needs A and B. So what do we do here? Does that represent, that's the correct representation? D also has A and B, the dummy B, and C also has A and B, the dummy B. Yes? So even this is done. And then you need an E that needs a D, and D was obviously 7. All good? Now you need a D that needs a E. So basically D that needs a E. And then E needs C and F. So probably and F is how much? 12. E is 10. So that makes your activity diagram complete. We did that a lot last week. Any dramas here? No? All good. See, you can still argue saying that I can make A as dummy as well. Right? But then normally, you see most of the books, the first predecessor is normally, if that's the case, I'll make A, B as dummy. Alright? Now, let's see how much is the minimum time I require this whole activity diagram, this whole activity sequence of activity to finish. So I'm trying to find the minimum time required to finish my project, to finish the project. This time is called the prime of critical path. And what is a critical path? Critical path is that path. See, how many paths do you have here? You have A from start to finish, if that's your start. So you have A, C, F. You have A, D, E, F. What else, Mohammed? B, D, E, F. Any more paths that you've got from start to finish that I've not done?
B, C, F.
B, C, F. Good. Anything else? Now, one out of these paths will be the critical path. Now, let's take an example. Did we talk about eating the breakfast, downloading the email? Did we talk about that? No? All right. Shall I take this off? Right? Probably I'll let it be there. Now let's say you're doing, there are three set of activities. Number one is download email, read email, eat breakfast. Let's say that's a schedule for someone. You sure we didn't do this, right? Okay. Let's say downloading email takes 1 minute, and this is in minutes. Reading email take 3 minutes, and eating breakfast needs 10 minutes. Now let's say it's this early morning schedule for someone, right? Let's say John. What can be the various sequences of events that can happen? That means if John starts these set of activities at 8 a.m. in the morning, what is the minimum time? What is the minimum time? By what minimum time he'll be out of the door? If suppose after eating breakfast he's just leaving for office, what is the minimum time? At what is the bare minimum time that he will leave the door? Tell me.
14 minutes.
You're saying by 8:14 he will leave the house. Is it?
If he completes
all of them. That's what you're saying? Now, is this not possible? Let's say this is breakfast is B, reading email is R, and downloading is D. Understand this, very important. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's try that. This is breakfast is B, reading email is R, and downloading is D. Understand this, very important. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's try that. This is 8 a.m. Let's see what the out time. If he eats breakfast, how many minutes do we need? 10 minutes? So let's say this is eating the breakfast B. So he finishes his breakfast at 8:10. Right? This is downloading the email and this is reading the email. Now, downloading email takes 1 minute. So he can start either here or here or here or here or here. Any of the 10 minutes he can start, right? Would downloading email and eating breakfast can go together? Yeah, if the laptop's in the front, you just click the button and start eating breakfast. The downloading will take 1 minute. So D and B are not sequential, right? So your activity diagram could be breakfast doesn't need anything else to start. So no immediate predecessors. This is immediate predecessors. Downloading email doesn't need anything. But reading email needs email to be downloaded. So reading email needs a downloaded email. So how will your activity diagram looks like? Breakfast and download starts in parallel. Yes, Tanu? And R needs a D. R needs a D. And breakfast and R are not here, so they can finish. So basically, that's my finish. Right? This is how my activity diagram will look like. If that's my start. Now, downloading can start the first minute. The moment downloading finishes, it takes another 3 minutes to read the email. Once he's done with these two activities, he still needs to finish his breakfast to go out of the door. So by what time he will go out the door? 8:10 and not 8:14 because of this. Right? Now, he can download here at the 6th minute. Can still read the email in 3 minutes and leave the house out at 8:10. So there's a lot of, what is this? There's a lot of slack in these two activities. There's a good amount of slack. He's got decent amount of slack to still finish, do everything and leave by 8:10. This slack or the leeway is called float. Activity D has a float of, it just needs 1 minute, right? So it can be delayed until, like, you see here, you cannot delay activity D beyond maybe the 6th minute, the 7th minute maybe. Because the moment you delay activity D by a minute more, you cannot finish reading by the time your breakfast is done. Right? So this D has a slack or a float of 6 minutes. At the max, he can delay re-downloading the email by 6 minutes in order to go out of the door by 8:10. The moment he delays this 6 minutes to 7th minute, he cannot leave the door by 8:10, then it will be 8:11. He delays, he might miss his train. If let's say 8:10 is the dot time he needs to leave home, you cannot delay activity 6 more than 6 minutes. Does that make sense? So this activity, those activities that can be delayed in a project, in your activities, without impacting your end time, are called the slack activities, or activities that have float in it. They are floating activities. They can float for a while. But eating breakfast cannot be delayed even for a minute. Let's say if he has to leave by 8:10 and breakfast needs 10 minutes, he has to start at 8 a.m. The moment he delays his breakfast by 1 minute and say 8:01, the train's gone. So this activity B or breakfast has no slack in it, no elasticity in it, or literally I should say it has no float on it. There is no float. And the activities that have no float on them are called critical activities. Critical activities. And all your activities in a network diagram that are critical, they make something called critical path. Does that make sense? So far, so good? Alright. Now, let's try to understand how do we calculate the float on various activities if we are given an activity diagram here. Right? Shall I take this off the board? A lot of you are feeling sleepy. If you want to catch up and have a glass of water, please do that. Please do. If anyone's feeling sleepy. Okay. Path 1. Who's giving it to me? ACF. What is the total time? 26. 6 plus 12 plus 14, 10, 22, 24. 24? 26. 26. The other one, next one, from A, is it A to D, A, D, E, F. What's the time?
35.
35. Guys, please cross-validate, right? I'm not counting now. This is the third one. So you've got two paths from A. What else? B. So you have B, C, F. What is BCF?
29.
BCF. What's the next one? B, D, E, F.
38.
All good so far? This path is taking the maximum time. And that is the minimum that is required for this sequence of activities to finish. No matter what is happening on top, this path is finished in 26, they still have to wait for another 12 minutes for all the rest of the activities on this path to get finished. So this path is the critical path. This path is the critical path. And I told you the float on this activity should be 0. You cannot delay them at all. It is just like eating the breakfast, right? Each activity is like eating the breakfast. The moment you delay on B or D or E or F, you've gone past 38 minutes. Right? So float on all the activities of B, D, E and F is 0. Will be 0.